So our goal for today is that we are going to solve a system of linear inequalities. So by way of review, remember that if you got this into y by itself form, and we said that y is less than, or y is greater than, then we're going to use a dashed line. And of course, solid line is if y was less than or equal to, or y is greater than or equal to. So it's the equal to part that makes that solid. Now what about shading up and shading down? Well, same scenario is I'm going to shade above if my y is greater, which implies also greater than or equal to. And I'm going to shade under the line for when y is less than or equal to. To approach this situation, we do have to graph these. We have to pay attention to what kind of line we have, solid or dashed. We have to pay attention to shading above or below. And we're going to have two scenarios at once. So your diagram could look very ugly. That's why pencil will be important. Now, I suggest here slope-intercept form, but it doesn't have to be. It could be any form. The big reason why I put it in slope-intercept form is because when you get y by itself, when you isolate y, then you can interpret in the manner we did up there. So let's just walk through and put these in slope-intercept form. And I'm going to keep the symbol greater than or equal to as well. So the first one here, I just subtract x from both sides. And now I have y by itself. Y is going to be less than negative x plus 3. As we see, we do need to do two things. I'm going to subtract x from both sides. And once I have that, I have 4y is greater than or equal to negative x. Notice I don't need to bring down the plus 0. Just leave it as such. And now I'm going to divide by 4 everywhere. And my final result here is going to be y is greater than or equal to negative 1/4 x. Yep. Once we have all this, interpreting the slope and the y-intercept, solid, dash, shaded, or above or below, that's all mental. Everything right here is mental exercise. This is just mental, but we're going to write it down here so that you can reference it and know from whence it comes. So on the red situation, my slope here is negative 1, and my y-intercept, remember b is my y-intercept. I begin at positive 3. What about solid or dashed? Is this going to be a solid or a dashed line right here? Good, that will be a dashed line. Dook, 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 dook. And am I going to shade above or below? Because of the less than, I'm going to shade below. How about my blue line? Solid line. And I'm going to shade above. Now, it's just coincidental that all this stuff is opposite. You could have both solid, both dashed, both shading above, whatever the case may be. So it's just mixed up a little bit. All right, so as we graph, I'm going to use colors. I have that option. So I'm going to start at positive 3 there. There's where my first one. And my slope is down 1, right 1. Or the other way is up 1, left 1. And that one I remember is a dashed line. So let me dash as I go. Dashing through the snow. All right, now what about my blue line? My blue line starts at 0. Why? Because the y-intercept is 0. All right, so let's check this. Now I start at 0 and I go down 1, right 4, down 1, right 4 like that. Or up 1, right 4 like that. And it's going to be a solid line there. Okay, now remember what we're doing. Pay attention to how we shade. For the red line, I'm going to shade underneath it, which means everything down here. For the blue line, I'm going to shade everything above. So what's the overlap? The overlap is in the middle right here. This is your answer. And we'll take more of a look at that tomorrow. Now, sometimes it's not going to be as straightforward as just two inequalities. Here are 3. So refresh yourself. What type of line is this one here? And what type of line is this one here? Good, we've got horizontal and vertical. Which is which? Well, this puppy here is the horizontal. And this puppy here is the vertical. And this last one over here is just your standard operating procedure. You have a place to begin, etc. So now the mental part is let's analyze things. I'm not going to worry about M and B for the blue one, but I know clearly that it's going to be a dashed line because of the less than. And I'm going to shade below because of the y is less than. We'll come back to the blue, or the red one, the vertical line, in a second. Notice that this one begins at -2. It has a slope of 1. It has a dashed line. And I'm going to shade above. So in this case, we have a solid line, and we are going to shade greater than the x. So this is the only context where we do not shade up or down. We shade, or excuse me, above or below. We shade left or right. All right, so let's attack, kill, destroy. The first one, the blue one, is the horizontal line is less than 2. So I place my y value at 2, and I do a dashed line crossing through that, like so. Next one, the vertical line's at -1, so I place a point there at -1, and notice that one's a solid line. All right, and the last one, I begin at -2 down here, and my slope is up 1, right 1, up 1, right 1, etc. And this one's a dashed line. All right, now that we've analyzed, or excuse me, we have our bounds, where do we shade? Good. Now, your instinct says we probably shade inside the triangle. And that's probably a good place to start, but let's just analyze it. Notice we're going to be under the blue line. Under the blue line is this half of the plane. Then we're going to be to the right, so it's anything over here, and finally above the black. So we are right. Ka-chow. So I shade in this region here. Let's go ahead and test this point right here. So we're going to check this.
Could you do like a decimal one? Be like,
yeah. Yep, you can do anything in there. In fact, this point right there, which is at -1/2, -1/2, you can do that. If we were told that everything had to be whole numbers, then we would only be picking, of course, the corners on my graph here. So, for example, this here, this here, this here, this here. Notice where we cannot. Nothing on this blue line is a solution. So this point, this point, this point, nothing on the black one is a solution. But everything on the red line is a solution. So we can test our point with any of those. But I'm going to test with 0, 0. And I'll just do it on the side here. So test with 0, 0. The first one says that that 0 is less than 2, and that's clearly a check. The next one says that 0 is greater than or equal to -1, so that's a check. And for the black one, we say that 1 is greater than 1 minus 2.
Wait, how'd you get multiplied by?
Good, yeah, so
0.
you're right. That's a 0 there and a 0 there. And 0 is greater than -2, also a check.